Welcome, students, to yet another wonderful day of a video presentation just for you. Mr. Sharber's here saying hello. Hopefully you're doing really well. I want to start today's lesson by talking about something that's great about this time. All right, it's always good to think about the positive things that are going on. So I'm going to say that there is no standardized testing, none. And you know what? You'd be doing it in about a week from now. So next week, actually, this week too, I'd have to take a look at the schedule, but I know that this week, as you're watching this video, instead of sitting in your sweatpants, hopefully sleeping in, spending time with your family, you would have had to wake up early and go and take a super long test that would really stink. And so now you don't. And that's a good thing. So let's start off with some positivity. That's awesome. Guys, we're going to get into a new lesson. This is a lesson that you definitely need to know for next year. We've been told by 8th grade teachers this is the number one lesson you have to know for going into algebra, which is going to be linear equations and slope-intercept form. So we're going to be taking this nice and slow. But hopefully this lesson won't take too long. We're going to get right into it right now. So when we talk about a slope of a line, that is how steep a straight line is. So if you take a straight line and you want to know how steep, if it's really steep or not, we call this magical word. And by the way, I have this super awesome pen that I got from my wife. That's a graphic design pen, and I'm super stoked because it's super awesome. Okay, the vertical change of the slope, whether it goes up or down, is called the rise. You're going to need to know these words, very important words. And the rise always seems to be positive, but it could be positive or negative. And the horizontal change, when you go left to right, is called the run. And these are the very important words you're going to need to know. In fact, you can even ask your parents, and they even may remember. And we're going to say that when you find the slope of any non-vertical line, by finding the ratio of the rise to the run. And we call it rise over run. I'm going to show you guys that in a second. So what does this really mean? Let's take a look at an example. So let's say if you leave home and you walk in any given direction at a steady pace, your distance, d feet, from home is directly proportional to the time, x minutes you walk. Don't really know what this means. Let's just take a look at a graph here. It says from the table, you can see the constant proportionality is 250. So for instance, this graph is you walking. And if I said to you right now, what is the slope of this? You know the slope. This is the most important thing for today's lesson. The only main thing you have to know, if you forget everything else, you got to remember this, is that it is rise divided by run. And that equals slope. Slope. And I'm going to put super awesome frilly, rise over run gives you slope. So I'm going to show you guys what that means. So if we start at one point, you can start at any point you want to. And we're going to start by doing rise first. We're going to rise up to 500. So the rise would be 500. And the run is left to right is 2. So what's the slope? 500 over 2 is going to be 250. And in this case, if you guys check here, that's very similar to, you guys remember, maybe way back in the day, the constant of proportionality, or what we like to call unit rate. What's the unit rate? Unit rate's kind of like the slope. It's 250. It's kind of like if you go here to here, it's always going to be going up by 250. And again, this is the slope. So before we get into it, if this didn't make sense, the good news is we're going to do a ton of examples. All right, so here we go. We're going to keep doing examples. Feel free to pause at any time to take a look at this. And let's do another example. It says the graphs give information about a penguin's number of heartbeats, B, over time, T minutes, during normal resting and just before diving. It says, when is a penguin's heart rate greater When is it greater? During normal resting or just before diving? I am so stoked about this pen. You guys know when you get like a super cool game on Xbox or you get something super cool for like a gift, like I got to tell you, I feel like an old man. I got this super cool pen and I am just stoked. Okay, so I'm going to write over here. Just remember that slope is rise over run. If we want to figure out which heartbeat is greater, we're going to do rise over run. Let's start at a point, any point you want to start at, and we're going to go rise 150. So rise is going to be 150 over the run, left and right. And we're going to take this and we're going to go to the right. 1, 2. So you guys can see that the slope here is going to be 75. What does this mean? 75 heartbeats per minute. Very similar to unit rate. 75 is 75 heartbeats per minute. So let's take a look here. Let's do it right before diving. That's going to be the rise is 400. And the run is going to be 2. And again, what is our slope? This is our slope. Very similar to unit rate. Again, very similar to unit rate. Is going to be 200. And of course, this 200 means beats. 1 second. Beats per minute. This is beats per minute. And we know that what's going to be greater, it's going to be right before diving. Right before that penguin dives off, you know, the heart rate's going to be going up a lot more. And we find that out by finding the slope or rise over run, which again is very similar to unit rate. Okay, let's take on another one. It says the graphs give information about the distance d miles traveled over time t hours by cars and trucks on a California highway. Which speed is slower? And again, we're going to find the slope of this, which is rise over run. So we start here. Let's start with the cars, and we can start, again, you can start at any point you want to. I always like to go left to right because we read left to right. And we're going to rise up 100. I just want to sing that one song like, and we rise up. Isn't that a song? I think. Maybe Alicia Keys or something. Every time I say rise over run, I want to say that. And so if we take rise over run, we're going to rise up 100. We're going to go over 1.5. And we can take out our trusty calculators, you know, our cell phones, and we can solve this. And I don't mind if you use a cell phone for this. And we're going to round this to speed of cars is going to be 66.7 miles per hour. So we go over to the trucks. I'm going to try to do this with my pen. No, we're just going to do it right here. Remember, slope is rise over run. Hopefully my face doesn't get in the way. And we're going to start here. We're going to go rise. We will rise up. Rise over run. 100 over that point you guys can't see. Let's just scroll, get my face out of the way. Is it 2? And that's going to be 50 miles per hour. And which speed is slower? You would say that the speed of trucks is going to be slower. It's 50 miles per hour versus 66. Great. And do you notice the last two? Do you see all these are positive? These are positive slopes. It's going up, right? It's going up over time. We're about to check out some negative slopes. And you still use rise over run. So here we go. Let's find the slope of a negative. So right here, guys, this is just a random view of like the stock market. Can you guys see here that in green, this is when it's positive, right? You notice how it's going up and that diagonal, like right here, that's positive, that's great. But the stock market doesn't always go up, right? Doesn't always go up. Sometimes it goes down. And you guys notice a pattern here. Look what's happening in red. Anytime it goes down, it goes this angle here. And so I want you to take a look at the next one, and you should be able to tell me right off the bat, is this a positive slope or a negative slope? So look in the red, has a similar path here going down, but look at the green. Green is positive. It's really easy to see once you do. Can you look at these next two? Can you tell me one of these is positive and one of these is negative? And if you understood that part, you should be able to tell me in about 3 seconds. And you should be able to tell me that this here is going to be negative and this here is going to be a positive slope. So how can you tell? You can tell over time, especially when you have an example. If it has a downward slope, it starts at the top and it goes down. And I'm going to start this out. It says find the slope of each line. I'm going to put a little indicator here that its slope equals rise over run. And you'll notice that it's not always positive. So we start at this point and look here. Do you notice which direction we're going? We're going down. Erase that. So it's going to be a negative slope. Take a look here. And I'm going to go from this point to this point. That's -1, -2, -3, -4, -5. I'm going to put a -5. And we go here, a positive 1, 2, 3, 4. A positive 4 from -5 to a positive 4. So our rise over run for this one, we're going to rise a -5 and we're going to run a 4. And guys, this is your answer. You're never, ever, ever going to put this into a mixed number. Leave as an improper fraction. And again, if you ever need to write this down, and you need to pause this video, just leave this as an improper fraction because this tells you the rise, this tells you the run. Very important. Guys, I'm going to show you something super cool. The great thing about math is that once something is right, it is always right. It's absolutely always right. So take a look here. Let's go the opposite way. You could start here if you wanted to. Let's go the opposite way. We're going to rise up 1, 2, 3, 4, 5. Isn't that a positive 5 now? If you go this way, I'm going to erase this, get this out of the way. You could do this way. I wouldn't normally do it this way, but you could. And that's a positive 5. But what happens here when you go +5 and you want to go backwards? What happens when you go to the left? When you go to the left, that's a -1, 2, 3, 4. And that's still going to give you rise 5. Your run is going to be a -4. And watch this, guys. 5 over -4 gives you the same answer, doesn't it? That's still going to be a negative slope. So this is a negative slope here, -5 over 4. Now let's take a look at the one right here. We're going to start here, left to right. We're going to rise 1, 2, 3, 4. That's a positive 4. And we're going to run 1, 2, 3. And we're going to say that our rise over run is 4 over 3. Super simple, right? Super simple. We're going to circle that. That is our slope, 4 over 3. But you know what? You could go the opposite way. That's an easier one. The question is, how do you go the opposite way? You could, and this is not to confuse you too much, I just want to show you why math is super awesome, is you could start here. What happens when you go down? What doesn't that give you? Doesn't that give you a negative number? -1, -2, -3, -4. That's a -4, right? That's a negative. And then we go from here to here. Isn't that a negative as well? -1, -2, -3. Isn't that a -3? If you guys see right here, if you're super awesome, what's a negative divided by a negative? Oh! You could start here. That's a -4 and -3. Doesn't that give you a positive 4 over 3? Doesn't that still give you the same answer? So that's why math is super cool. You could go both ways. You could actually go down negative and do a negative. And that's perfectly fine. It will give you the same answer no matter what. Okay, we're going to do 2 more. And again, if you think you can do this and you want to pause it right now or skip through this to kind of say, hey, I got this. But I'm going to start here. And then you guys see how this is a negative slope. We're going to start this dot. And we're going to go down 1, 2, 3, 4. That's a negative 4. And then we're going to go to the right. 1, 2, 3. That's a positive 3. Remember that slope is rise over run. And we're going to say that this is a rise of negative 4 over 3. There you go. And we can do the next one as well. We're going to start at this point. We're going to rise. We're actually going to go down 1. That's a negative 1. And we're going to go over 1, 2, 3, 4, 5. That's a positive 5. So you guys can see here on this slope, the rise is negative 1 over a 1, 2, 3, 4, 5. Make sure I got that right. That's going to be negative 1 over 5. And we're going to circle these. Again, I don't want to confuse you too much, but you could have gone the other way. You don't have to. It doesn't matter how you solve this. I'm going to erase this real quick. We're going to solve it the other way. You could have gone this way. I'm so stoked on this pen, by the way. It's like the best pen ever. That's a positive 1. And you could have gone negative, right? That's a left. Going to the left is negative 1, 2, 3, 4, 5. That would be a negative 5. And you could have had a 1 over negative 5. And that gives you the same answer. Same answer. Super cool. The slope here is negative 1 over 5. All right, guys, we have just these 2 more examples left. What I'd like you to do right now, because you're accelerated, is these are answers. We have a horizontal and we have a vertical slope. The question is, can you use your math skills and tell me what is the answer to the slope of these? Because they're going to have unique answers. But they do have an answer. They do have an answer. And so if you like to right now, I wouldn't mind you pausing and seeing if you can guess what's the slope of this and what's the slope of this. If you don't want to pause it, that's perfectly fine. We're going to go through it right now. So remember that slope, and you can use your math skills to solve this, is rise over run. We know that. Mr. Schreiber said it 1,000,000 times. So just pick a point. You know, which point do you pick? How about we pick this point and this point? Doesn't really matter. You can do this with any line. And guess what? We're going to rise up how many? How much can you rise here? How much can you go up? You can go up 0. You can't go up at all. You can go up 0. So in this case, the rise is 0. And what's the run? Well, it doesn't really matter what it is, but the run would be, let's go from this point to this point. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0 over 15. So what does that give you? What is 0 divided by 15? 15 goes into 0. Ta-da! 0 times. So our slope, anytime it is a horizontal line, and you're going to see this, just a heads up, you're going to see this on the checkout problems, is anytime you have a horizontal line, you can use your math skills and you're going to realize that the slope is 0. The slope here is 0. Doesn't matter what you do. The rise, you're going to rise up, always 0. You can't go up anymore. Okay, so the question is this one also 0? And the answer is no. It's not always 0. Well, let's take a look. How would you solve this? Now, a lot of students like to memorize these, like this one's always 0, this one's always the other thing we're going to talk about. But I'd like to use you to use your math skills. So just pick 2 points. How about we pick this point here, and we pick this point here. And I said, find the slope of those lines. Well, we know, again, that slope is rise over run. So how about we rise up how many? 1, 2, 3, 4, 5. We're going to go from here to here, and we're going to rise up 5, right? So the rise is 5. What's the run? The run, how many can you go over? How much are you going left to right? If you answered 0, you are correct. Now, here's the thing. Who's super awesome at math right now? Those people who are watching this online, who's super awesome and can tell me, does this value give you 0? And here's what I'd like you to do. If you don't know, take a calculator out or take your cell phone out. I want you to divide this, and this should happen. Your calculator will explode. No, it won't explode. It won't explode, people, but it should read something like this, which means it is undefined. Undefined. And that is what we call this. We cannot define this slope because it's not zero, right? This is another beautiful thing about math. Why isn't, 5 divided by 0? Why isn't that 0? Why isn't just it 0? Because, 0 can go into 5, 0 times. Why isn't it 0? And this is a graph that shows it, and I get super stoked about it because why isn't this 0? Because is this a 0 slope? No, it's not a 0 slope. It's not a flat slope. It's undefined. We can't tell what the slope is because it's like goes on forever and it goes straight up. We can't really define the slope, so we call it undefined. So anytime you have a vertical slope, vertical always is undefined, and anytime it's horizontal, it's always 0. This is technically right, but I would like you to solve that and just put 0. Super cool. And guess what, everybody? We are done. We're done. And it's time for you guys to complete your linear equations. Check out problems number 1. Big thing is, if this did not make sense and you would like some one-on-one help, just contact me. I'm debating whether we're going to do like a conference with students so I can go over this. I'd like you to see if you can do it on your own. But if you need some extra help, just let me know. Good to see you. I hope you're doing great. I hope you're sleeping in and you're just having this wonderful time with your family, playing some board games. A board game I wanted to play recently is Monopoly. Mrs. Calla, if you can ask her, she was playing Monopoly with her family. And then I remembered all the stories of me playing Monopoly with my brother and my family and how crazy I would be because someone, like right when I land on like Boardwalk and I have to give up all my money and how just like it, people talk about Monopoly like tearing families apart. Well, I think I want to try it again because I remember I still love that game. And so I'm going to try it out. I'll get back to you. And you guys have an awesome one. And we'll talk to you soon.